I'm a trailblazer. I'm an agent of change. In the capacity of working for a research organization, I have the opportunity to work with organizations on innovation, and every day I see what sort of makes innovation succeed and when it fails. And I felt that innovation is about achieving big things, and I feel it's very close to the ambition also from Q2B, because clearly getting quantum technology to use and to make it practical for solving complex problems, it is quite a big feature. So I felt big things and accomplishing them is what I do, and I recently came across a book that has the same title, and it has some interesting concepts that I wanted to share with you. This session is about case studies and use cases, and as I like verbs over nouns, I would say I'll talk about using cases for you to leverage and utilize. And I'll cover those three key insights that came from the book. One is think right to left, and then for language scripts that sort of run from right to left, it's the other way around, of course, like Urdu and Farsi. But starting at the end is for me a useful way to think about what is needed to accomplish the result. And in my talk in a couple of minutes, I'll show you that for me, it is much more about explaining what quantum does than what it is. The second insight is that big things are team efforts. They say, if you want to go fast, go alone. If you want to go far, you go together. And I think as there's no single company yet that will deliver applications, useful applications, or anything like exponential speed up as a service, I think it's fair to say that now developing use cases is a team effort. And then finally, also, big things are typically about starting small. And that's no pun intended, but something small is overseeable with meaningful milestones towards larger end goals. And then a fourth insight that I won't cover, but still sort of thought-provoking, is that you have to know that the biggest risk is yourself. So I'm guessing I shouldn't be here on the stage next year again. But anyway, knowing that sometimes you are part of the problem is, I think, thought-provoking and good to realize if you want to get big things done. So I have three insights, and I'll start with the first one, which is starting at the end. And if I apply that concept, I should start with a B, right, from the business. So just to ask in this room, who would sort of consider himself or herself part of the group of end users, the business? Not too many, so I'll have to think of this when doing this presentation. But so the business side, or let's say demand, and then supply side, if I follow the law of the excluding third option, I'm just guessing that anyone else is on the supply side working from essentially, can I make it, to business, which typically comes from the angle, can I use it? And both are fair perspectives. I'm agnostic about where to come from. I'm just saying that this talk about innovation is meeting somewhere in the middle. And meeting somewhere in the middle will require a lot of hurdles to overcome. First one, technical. I think these 2 days are all about technical stuff like error correction and fidelity and noise reduction. I all consider them as a class of technical challenges to be resolved in order for us to get from quantum to business. Engineering problems, packaging problems, again, many people working on those as well, typically coming from the Q side towards the business, and then scientific challenges and algorithm development as well. Typically when I talk with people from the B side, so to speak, to be frank, they don't care about quantum. You know what business and clients want? They want solutions. And again, it's a bit blunt, but just sort of as a mind shift, as a paradigm shift, in order for them to get solutions, it doesn't matter what type of challenges are remaining. It's going to be a combination of all of those. So even on financial, which may be trivial, if you build the most perfect technology, but it's unaffordable, or there's no business model that you can sustain the technology with, it will be a challenge to get big things done. Legal stuff, especially on quantum, I think there's a lot of aspects that you have to care of, sanctions, potentially also compliance, legal frameworks, open source, export control, all type of aspects that you have to cover while getting this technology to use, and then human capital, the war for talent as well. There's something missing here, and that is the know-how. So know-how, I think, is important when thinking about technology innovations, and in a way I thought, well, haven't we been here before? And then part of this quantum application lab that I'm representing is the University of Amsterdam. And although I think the university in Paris, Sorbonne, is over 800 years old, I think, University of Amsterdam has been established in 1632, so that's close to 400 years. And by then also technology was advancing very rapidly. So again, we've been here before, and the one white male with sort of the formal clothing and the mustache and the beard, there was the inventor of the telescope, and the other guy was the inventor of the microscope, which is a way to sort of say, well, there wasn't much diversity then in those times, but either way, both gentlemen were Dutch, and ever since that time, and ever since in the Netherlands, there has been a culture, sort of cultural DNA of innovation, collaboration, and technology development. And as much as I should now sort of stop bragging about the Netherlands as a natural place and breeding ground for innovation, I wanna move on to the second insight, which is that getting big things done is typically a team effort. So I mentioned a bit about TNO, the research organization, and UvA, the University of Amsterdam. The Quantum Application Lab for application development and doing use cases is actually a group of 6. It says CWI, which is the National Institute for Mathematics and Computer Science. eScience Center is the National Institute for Research Software Development. Quantum Inspire is the platform from QTech. SURF is the National HPC Cluster. And those 6 organizations essentially are there to develop applications. It's an open R&D collaboration, field lab type of setting. And we engage with any leading qubit technology or quantum mechanics. Here's a few of those, but we hope to liaise with many more as the technology matures. And clearly the most important group is missing here, and that is the participants in our collaboration, so working with industry and working with private sector companies. These are a few. It is the introduction of my third concept, and that is starting small. So whenever you would envision doing postdocs, PhDs that will have engagements for 4 to 5 years, we would try to apply a pressure cook mode with 4 to 5 months duration, typically a flexible in and outflow of companies, business with their problems. They're here on the right. So for example, in healthcare, can we do something in the detection and the diagnostics in brain cancer by computational imaging? Again, a group of work that may not necessarily have quantum on their radar, but is looking for speed up. And then we reverse engineer and we try to come up with solutions. These are a few. Typically, we would open source whatever we can and close source whatever we have to. But it's an illustration of starting small with use cases or case-driven approaches for application development. And I'll highlight one in particular, and there will be a separate talk later this afternoon in a panel discussion by Marcin Dukowski, who's also in this audience, and the team from TU Delft. It was about a shallow anomaly correction for subsurface imaging. And I'll just mention two, and I'm not going to cover the content because it's if you are interested, then by all means you can read it online. But first, there's the sort of the quantifiable or measurable result there that most researchers will get their attention immediately. It's the 15% number. Of course, again, I'm not going to challenge this, but what it does is for stakeholders, it's a way to start a conversation with senior management about the potential impact and again, the use of quantum. And along there, you will see that you'll be exploring many technologies and many different qubit technologies, but in a way it's much more here about getting to impact. And the other thing I'm particularly proud of is that this engagement, this case study, has led to the establishing of a quantum computing team within the company in Europe, and I feel that is quite a big achievement. Aramco is in terms of market capitalization, it's top 5 in the world, and that is, I feel, a testament in what we can do now and what you can achieve by doing small use case driven collaborations, knowing that in future perhaps when the technology matures and advances, there's much more benefits to be gained. So wrapping up. And this is a reference to the fact that in the Netherlands there are small buildings, so typically elevators pitches are much shorter than if you would say go to the Middle East or America, where you have at least 5 minutes in an elevator. But so the opportunity there, depending on your perspective, I guess the opportunity or the challenge is that there's going to be the introduction of quantum technology in business environments. Either you act or you don't, but that is what we see. Then I hope from this quick talk you see that for forward-looking organizations, the Quantum Application Lab is an open R&D type of field lab that you can leverage and utilize to design, develop and deploy useful applications with benefits like de-risking future investments, establishing initial thoughts about resources, talents and IP strategies, and that it also leverages the scientific integrity from the whole group, in addition to whatever you're doing with industry parties and the market. Ultimately, getting your business to be connected to the Q from quantum. This is where you can find our stuff, and then working again from the end upwards. Most important here, as we're not a not-for-profit, we don't have a fancy website, but we do have a GitHub repository where we publish again all the results that we hope lead you to incremental use and deployment of those examples and the code. We are proud to be part of Quantum Q2B, but also other events that ultimately want to drive progress and application development. And the last thing I'll say is that on the topic of diversity that I also alluded to, 10 minutes to 3, there will be a photograph here, I think, for women in quantum. So we hope to see, well, lots of women in this case that are active in the field of quantum, because we really want to drive that agenda as well.